scientists have been observing the universe for many decades. Thanks to technological advancement, we have been able to peer into the furthest reaches of space, discovering thousands of exoplanets and countless distant stars. But of course, the celestial bodies within our solar system are no less important. And today, we're going on a fantastic journey to the nearest ones. Our journey begins on the hottest place in the solar system. Together with the Parker space probe, we will plunge into the tempestuous ocean of solar plasma to see for ourselves what the giant prominences and dazzling flares on the surface of the Sun are like. From there, we will move on to visit the scorched Mercury, a planet of contrasts, where there are metals boiling in one place, and in another, there are layers of eternal ice. Next, it's time to visit the fog-shrouded Venus, with its incredible thunderstorms and acid rains. Next, our journey will take us to the surface of ancient Mars, frozen in eternity. In search of hypothetical life, we will climb the tops of giant mountains and descend to the bottom of monstrous canyons, fly over rugged plains, and touch the bottoms of long dried-up lakes. Finally, leaving the red planet behind, we'll head to the mysterious Asteroid Belt to explore its most remarkable objects. We don't yet know where we'll get in the end. Let's get ready, and we begin. Kosmo. The first in outer space. On the 21st of November 2021, the Parker Solar Probe was just 8.5 million kilometers away from the Sun. It was its closest approach ever to our star. This means that it was also the first probe that got to brush against the Sun's corona, the extremely hot outer layer of our parent star. But why was it necessary to go through a number of technical difficulties and approach the Sun that close? What is Parker after that it had to get that near the star, to areas where everything around turns into ash? To realize the purpose, we have to see what we already know about our system's star. To begin with, the Sun is a main sequence star whose age is approximately 4.6 billion years. It currently falls into spectral class G2V, which on balance makes it a typical yellow dwarf. The Sun's surface temperature is about 5,800 Kelvin, which is 5,530 degrees Celsius, but it should be mentioned that there are both colder and hotter areas to be found on it. Incidentally, the star's inner layers and its outer corona are as scorching hot as millions of degrees. But for all that, they barely contribute to the visible radiation. The Sun's average diameter equals around 1.4 million kilometers, which is 109 times that of our Earth. As for the star's mass, it reaches 2 times 10 to the power of 30 kilograms, or 333,000 times that of the Earth, and actually accounts for 99.9% of the mass of the entire solar system. We're used to seeing the Sun as small, but in fact it is larger and brighter than 80% of all the stars in our galaxy that we know of. Hydrogen accounts for 92% of the Sun's overall volume. In one of our previous videos on stellar evolution, we mentioned that it is mainly this gas that fuels thermonuclear reactions for the overwhelming majority of stars when its temperature reaches incredibly high values. As they merge, hydrogen nuclei release great amounts of energy and transform into helium, which gradually accumulates in the star's center. At the moment, helium accounts for 7% of the Sun's volume and 25% of its overall mass. In addition to helium, stellar matter contains other elements as well, like carbon, oxygen, nitrogen, and iron, but their percentage is quite negligible. The Sun has an elaborate structure and is made up of several layers which differ in their properties. A massive core is at the center of the star. Estimates show its diameter to measure 25% of the Sun's overall size. The core's temperature measures as much as 14 million Kelvin, while 1 cubic meter of the material weighs around 150 tons. It is here that thermonuclear reactions, the source of energy for our star's luminosity, run their course. Every second, approximately 4.26 million tons of stellar matter is transformed into luminosity as a result of these processes. The core is surrounded by the so-called radiation zone, which continues to the point of 0.7 the Sun's radius. The density of matter in this area is too great for it to get mixed up thoroughly, and thus to carry heat to the upper layers of the star. That is why the way energy is transferred here is this. Particles of stellar plasma are continuously absorbing photons and radiating them again. Mathematical modeling shows that the temperature in this part of the star dramatically changes from 7 million Kelvin in its depth to 2 million Kelvin on the outer boundary. Estimates reveal that a quantum of light produced by the core may stay in the radiation zone from 10,000 to 170,000 years, and only then to move on to the next layer of the Sun. The one lying above, known as the convection zone, forms the Sun's outermost layer and is comparatively dense. Stellar matter here is more rarefied and changeable, which gives rise to enormous vortices in the convection zone. These vortices carry hot plasma from deeper regions of the layer to the star's surface, as it were, while plasma masses from the outermost areas, slightly cooled, move down. These convection cells remain stable for 10 to 15 minutes, after which they get destroyed to give rise to new vortices again. This continuous movement of matter creates a magnetic field, which pervades the entire inner part of the solar system. The Sun is also surrounded by an atmosphere. It is made up of several layers of elaborate structure. The lowest one is called photosphere. This area emits most of the star's visible light, so when watching the Sun, it is actually this photosphere that we see. As for its thickness, it measures from 100 to 400 kilometers, with a temperature fluctuating between 6600 and 4400 Kelvin, or between 6330 and 4130 degrees Celsius. Higher up lies a more rarefied area around 2000 kilometers thick, known as the chromosphere. It can be observed from the Earth at the time of a total solar eclipse, or else by employing special equipment. This area is extremely hot, with the temperature fluctuating between 4000 Kelvin and 20,000 Kelvin. Interestingly, its outer border is covered with spicules, continuously active jets of hot gas spurting up a staggering 5,000 to 10,000 kilometers high. The uppermost area of the Sun's atmosphere is called the corona. It consists of giant prominences, flares and emissions that may reach 1 million kilometers in size. The matter making up the corona is remarkably rarefied and incredibly hot, with an average temperature of 1 to 2 million Kelvin and the peak at 20 million Kelvin. It is this area that is occasionally crossed by the Parker probe, and every time the spacecraft immerses deeper and deeper into the blazing abyss. Calculations of the energy flow released by the photosphere will show it to be insufficient to heat the chromosphere and corona to such mind-boggling temperatures. This means that there are some physical phenomena concealed in the Sun that we have not yet discovered, which additionally heat up the upper layers. There are several scientific hypotheses that attempt to account for this thermal paradox. According to one of them, the chromosphere and the corona gain additional energy by dispersing magnetic shock waves. Another assumption explains it as an effect of charged particles' acceleration in the star's exceptionally powerful magnetic field. The Parker Solar Probe was specially designed in order to get to the bottom of these phenomena and to study obscure processes in the upper layers of the Sun's atmosphere. This probe is part of NASA's project known as Parker Solar Probe, launched back in 2009. 9 years later, on the 12th of August 2018, Parker took off from the surface of our planet on its one-way journey to the Sun to fulfill its mission. However, before getting that far, it had to execute a number of maneuvers to enter the desired orbit. By using Venus's gravity, Parker slowly adjusted its trajectory, drawing ever so closer to the scorching blazing ball in the center of our system. It was ready to withstand the star's searing heat. The probe had been designed with a heat shield, and all the equipment had been made with a view to extreme conditions to be faced. Besides, Parker's calculated orbit is supposed to lie in the Sun's immediate proximity for a comparatively short time, after which it pulls back and has a chance of giving out heat to space. This alleviates effects of thermal exposure. The probe's main task is to define the structure and dynamics of the magnetic fields in the Sun's immediate proximity. Also, Parker is supposed to gauge the energy flow emitted by the star, to capture particles of stellar wind, and to register wave-like processes in the Sun's corona. As a side mission, the probe took photos of Venus and the comet Neowise as it was drifting towards our parent star. To deal with the missions successfully, the probe is equipped with a wide range of scientific instruments like photo cameras, instruments for capturing particles, magnetometers, as well as radiation and radio wave detectors. A number of factors toward this mission. In addition to critical temperatures, the measuring instruments are exposed to an extremely powerful flow of ionizing radiation. The Sun creates strong interference in the microwave range around itself, which means that transmitting the data collected by the probe to the Earth is no easy matter either. Still, the Parker probe is carrying on with its mission. With every completed spiral of its orbit, the distance to the star shortens. In late February 2022, it is to pass through the Sun's corona yet again, in order to collect a new portion of data. By 2024, the distance between the probe and the surface of our star will shrink to become an all-time short, just 6.5 million kilometers. Estimates show that when the probe is in its perihelion, its solar shield may heat up to 1,370 degrees Celsius, which is 3 times hotter than Mercury's sunny side and only slightly lower than the melting point of iron. Even now, the probe is whizzing at a speed of 163 km per second in its perihelion, but it will eventually accelerate to 200 km per second, which will make it the swiftest man-made space object made so far. The probe's life expectancy cannot be that long. On reaching the closest possible point to the Sun, Parker will manage to complete several orbits around it, which is supposed to take roughly a year. All this time, it will keep losing speed, and the scientific instruments on board will be exposed to extreme temperatures and powerful radiation. Eventually, they will all be out of order, and the probe itself will descend into the scorching depths of the Sun, to be totally swallowed up by a fathomless ocean of blazing plasma. But before it happens, Parker will beam great amounts of useful data back to the Earth, which will help us make yet another step in space exploration. This is a potent proof that Parker's flight will not have been wasted. Mercury lies relatively close to the Earth, but its exploration has always been associated with a lot of difficulties. On account of its close proximity to the Sun, it can be observed in the sky only at the very horizon, and this either shortly before sunrise or immediately after sunset. This is actually why ancient astronomers took Mercury for 2 different celestial bodies, which were given different names. Only the advancement of observation equipment enabled scientists to gradually reveal some of this unusual world's mysteries. The accumulated data shows Mercury to be the smallest planet in the solar system. Incidentally, it is even beaten by some satellites. Its radius measures 2,440 kilometers, which is roughly 38% that of the Earth. The celestial object is remarkable for its almost ideally round shape, as the difference between its equatorial and polar diameters is not over 1 kilometer. At the same time, given its modest size, Mercury has a surprisingly big mass. It equals 3.33 times 10 to the power of 23 kilograms, which is approximately 5.5% that of the Earth. Comparing Mercury's parameters with those of celestial objects close to it in terms of their size, Mercury is heavier than Ganymede and Titan put together. And that in spite of the fact that both of those objects' diameters are bigger. It is probably due to the fact that there is a massive metallic core with a radius reaching as much as 2,000 kilometers, accounting for about 57% of the planet's volume. The core is enveloped in a 400-kilometer layer of mantle made up of molten silicate rocks. The mantle, in its turn, is covered with a hard crust as thick as 15 to 37 kilometers. As for the planet's surface, it is vastly pockmarked with craters. Their analysis shows the celestial body not to have been noticeably geologically active for the past 3.8 billion years. Bright sunlight presents difficulties in observing Mercury through a telescope. However, this had been the only way of studying the planet until as recently as the second half of the 20th century. Everything changed in 1974, when the space probe Mariner 10 reached the planet's environs. It took pictures of 45% of the celestial body's surface, and also gauged its temperature and magnetic field. In addition to that, the probe's sensors registered the exceptionally rarefied atmosphere made up of helium and other gases. 30 years later, on the 3rd of August 2004, another spacecraft took off the face of the Earth. Messenger. It took a long 11 years to reach its target, but the little probe did tackle all obstacles and eventually accomplished its mission. In the period from 2011 to 2015, Messenger beamed back hundreds of thousands of images for scientists to study, including pictures of Mercury's almost entire surface. Thanks to these pictures, important data was obtained on the celestial body's inner makeup, and various features of the planet's relief were detected, including unique ones in the solar system. Also, Messenger's sensors helped supply us with some knowledge about solar wind and its unusual interaction with the planet's magnetosphere. Mercury follows an elongated elliptical orbit around the Sun, which takes 88 days to complete. In its perihelium, the planet approaches the Sun as close as 0.31 astronomical units, with the distance in the aphelium 1.5 times as big, at 0.47 astronomical units. Mercury's orbital resonance, unique in the solar system, is of special interest. Its stellar day equals 58.65 Earth days, which is 2/3 of the Mercurian year. This makes the planet to face the Sun alternately, first with one side, then the other in the perihelium. These regions are exposed to solar radiation most, and are referred to as hot meridians. One of such regions boasts the largest geological formation on Mercury, designated on maps as Caloris Planitia. This name, which is translated as a heated plain, is fully justified, as the temperatures here reach 700 Kelvin or 427 degrees Celsius, making this area the hottest place on the planet. The plain is a gigantic impact crater measuring 1,550 kilometers and accounting for about 2% of Mercury's total area. Estimates show the crater to have formed approximately 3.9 billion years ago, after a collision of the planet with a large asteroid measuring as much as 100 meters in diameter. Mercury was a young and hot protoplanet at the time. The impact would have destroyed a great portion of crust that had barely solidified, and molten lava would have spilled over a vast area of the planet's surface. When it cooled and solidified, the plain was bound by a rocky crust, looking like a bright light spot easily noticeable against the dark valleys surrounding it. The surface of Caloris Planitia is pockmarked with a great number of craters measuring up to 100 kilometers in diameter. However, the most outstanding feature on this plain is Pantheon fossae. Unique in the solar system, this structure is formed by a radial set of 230 troughs, or extension faults, with a width from 1 to 8 kilometers. Most of the troughs do not measure over 175 kilometers in length, with others running much further than that. There is a comparatively large crater, Apollodorus, lying not far from Pantheon fossai's central point, but it is still not clear whether it has anything to do with the troughs. Today there are several hypotheses as to Pantheon fossai's formation. According to one, the giant cracks appeared due to tectonic activity, while another deems the planet's cooling as the reason. Caloris Planitia is an area of flames and light, However, moving slightly to the north, we will find a land of ice and darkness. The tilt of Mercury's proper motion axis is very small, which is why its polar regions are perpetually enveloped in dusk. The sun here either hangs by the very horizon or does not appear in the sky at all. Its rays haven't touched the bottoms of some of the craters for as long as millions of years. There is no wonder that Borealis Planitia, a plain surrounding the planet's north pole, is the coldest region here. The temperature in some of its areas is around 80 Kelvin, which is 193 degrees Celsius below zero. Some deposits of water ice have been detected here in the shade of the mountain ridges around craters. Measuring up to 2 meters in thickness, they are covered by a layer of rocky dust, preventing the ice from evaporation. At the same time, some elevations, which do catch sun rays, may get as hot as 380 Kelvin, or 107 degrees Celsius. Interestingly, such contrasting areas of the surface may lie almost next to each other, but the planet's rarefied atmosphere does not allow them to effectively exchange heat, and so the stark temperature contrast remains. Our tour is getting us to more southern latitudes. Practically on one parallel with Caloris Planitia, but 3,500 kilometers to the west, there is one of the largest craters on Mercury, Rachmaninoff. Its diameter measures up to 290 kilometers and it's roughly 1 billion years old. There is a tall peak ring in its center. It is formed by tall mountain peaks and measures roughly 130 kilometers in diameter. The rocks in this area are different from the rest of the landscape. They are of a reddish hue, and signs of solidified streams can be distinguished on the surface. This structure is assumed to be of volcanic origin and is a mark of one of the last volcanic activity events on the planet. Also, the lowest point on Mercury's relief has been registered here, which is minus 5,380 meters relative to the average value for the planet. Beyond the central ring, there are comparatively smooth and dark expanses. Moving on to the south, we will see a gigantic escarpment stretching for 820 kilometers from southwest to northeast. It is called Enterprise Rupees, which in some places towers as high as several thousand meters. There are quite a few escarpments on Mercury, but Enterprise Rupees is the largest. These bizarre features of terrain are believed to have formed as the planet cooled. When Mercury's interior gave away some of its heat, the celestial body slightly shrank, losing roughly 1% in volume. This deformed the planet's lithosphere, which produced gigantic folds. Almost half of Enterprise Rupees is located on the territory of Mercury's largest crater named Rembrandt. Its diameter measures 716 kilometers, and the wide basin contains a great number of smaller features of relief. For example, there are small mountain ridges running from the crater's outer ring to its center. Their width lies within 1 and 10 kilometers, and their length may reach 180 kilometers. Another ridge forms a ring roughly 450 kilometers in diameter. There is also an elaborate pattern of deep cracks to be seen on the crater's bottom, which resembles a spiderweb. It is believed that more detailed studies of the rocks forming the crater's surface should help us better understand Mercury's inner makeup and the processes running in its interior. In spite of close attention paid to Mercury by astronomers, and in spite of the advancement of observation equipment, the planet is still mysterious and largely understudied. However, even Mercury cannot stay unexplored forever. Even at this moment, the Bepi-Colombo spacecraft is on its way, rapidly approaching this celestial body. It is a joint project of the ESA and Japan. The equipment on board the spacecraft will help collect data on the planet's surface and atmosphere composition, study the magnetosphere and solar wind, and update information on the relief features. Bepi-Colombo has passed Mercury before, but there are still a few elaborate maneuvers to perform up ahead to break speed and enter operational orbit around the planet. It is estimated that this will have happened by 2025. after which the spacecraft will go on to collect and transmit data. Venus is the Sun's second closest planet, lying 0.72 astronomical units away from the system's center. Its orbital period equals roughly 225 Earth days. Interestingly, every 584 days, the distance between Venus and our planet shrinks to its smallest at approximately 0.25 astronomical units. Notably, Venus faces the Earth with one and the same side throughout their closest approach. There is no hard evidence to account for this fact, but it may be either due to the tidal forces exerted by our planet, or else it could be a mere coincidence. In terms of its physical characteristics, Venus resembles the Earth in many ways. Its average radius equals 6,052 kilometers, or 95% that of the Earth, and its mass is 4.87 times 10 to the power of 24 kilograms, which is 0.82 that of our planet. Every 243 days, Venus completes a full rotation on its axis, and the rotation axis is tilted at 3.4 degrees with respect to the ecliptic plane. For a long time, Venus has concealed its real face from observers on the Earth behind a veil of its dense atmosphere and thick clouds. This gave rise to a whole plethora of highly imaginative hypotheses and assumptions. Some of them claimed that there was a highly advanced civilization concealed under the planet's impervious outer layer, while others suggested that there was a world that was home to peculiar life forms. Until a certain point in the recent past, assumptions about Venus were to be confined to the realms of fancy. Space flights and the advancement of radio location technologies proved to be a major breakthrough that made the desired answers closer than ever. For example, it turned out that radio waves of a certain range pass freely through the planet's atmosphere and get reflected from solid rocks. This effect made it possible to make the first maps of Venus back in 1978 by the orbiter Pioneer Venus 1. Soviet orbiters contributed to the collected data, but the maps were accurate up to 1 to 2 kilometers and outlined only the largest features of the Venusian terrain. This is the reason why it was necessary to go on to send the Magellan orbiter, a large specialized radar. In the period from 1990 to 1994, images of 95% of the planet's surface were beamed back to the Earth by the spacecraft. Interestingly, their resolution reached 120 meters. The information collected by the Magellan spacecraft is still considered the most exhaustive and accurate data about the Venusian surface. Before talking about any planet's surface, it's worth looking at its inner makeup. According to the most reliable and well-grounded theory, Venus has a metallic core at its center, whose mass accounts for as much as 25% of the planet's overall mass. Observations show that Venus has no magnetic field, which is why the metallic core is more likely than not in a solid state. It is embedded in a silicate mantle as deep as 3,000 kilometers. Its upper layer is a solid crust, whose average thickness measures as much as 16 kilometers. It is posited that Venus's lithosphere doesn't form tectonic plates on account of high temperatures and a high viscosity of the rocks. This makes the planet's geologic activity quite different from that on our Earth. Venus is also peculiar for not having that many large impact craters. Large areas of its surface are covered by basalt plains that formed from solidified lava. Some features of the relief found here are uniquely Venusian and are not to be found on any other planet in the solar system. An example of these is tesserae, highly ragged mountainous areas resembling roof tiles. Arachnoids and coronae are two other unique types of the planet's terrain. Round or oval structures with diameters measuring several hundred kilometers. They appear to be impact craters, but their origin is different. Rather than celestial objects in fall, they formed as a result of tectonic processes. An unprepared viewer will not easily notice any features of the Venusian terrain even in processed images. That's why let's take a look at the elevation map of the planet's surface, where areas of different height are marked by contrast colors. The region that instantly catches our eye is the largest elevated feature on Venus, nicknamed Aphrodite Terra. Areas like that may well be considered conditional continents of the planet. Aphrodite Terra is a gigantic territory stretching along the planet's equator. Its mountainous relief is rather elaborate. According to different estimates, the length of Aphrodite Terra may reach 18,000 kilometers and the width around 5,000 kilometers. Depending on the method of defining the continent's borders, its area is estimated in the range from 29 to 41 million square kilometers, which is comparable with the area of Asia. If we look at Aphrodite Terra, we will see three vast areas: Atla Regio, Thetis Regio and Dovda Regio. The first one of these is located in the eastern part of the continent and is notable for the highest volcano on Venus, Mart Mons. The distance from its foot to its peak measures around 5 kilometers, and the overall height above the average level of the celestial object's surface is anything from 8.3 to 8.8 kilometers, according to different estimates. The volcano is currently dormant, although there is evidence that it erupted comparatively recently in geological terms. Namely, it can be inferred both from solidified lava flows and lack of impact craters on the volcano's slopes. Dovda Regio sprawls in the western part of Aphrodite Terra. This is a region particularly attractive in terms of tectonic processes. The mountain ridges here run in different directions, which means that there are several forces tearing at the crust simultaneously and deforming it. Moreover, deep crevices have been discovered here that contain traces of lava spillage. These may well be considered the most bizarre volcanoes on the planet. We're moving on to the west, to the very edge of the continent, where the alleged descent points of 4 Venera probes can be found, and 2 of the probes were destroyed by the planet's atmosphere before reaching the surface. All these are located in the southern part of a vast lowland region known as Guinevere Planitia. It stretches for many thousands of kilometers and is quite a match to Aphrodite Terra in terms of area. Even though it is called a planitia, the area has an elaborate relief, which is a mixture of various geologic formations. It is thought that the planet's crust was being crumpled by tectonic forces for many hundreds of millions of years, and this produced the ridges and the folds. At the same time, the lava spilling from the crevices spread across and solidified, filling the lowlands with smooth basalt plains. As a result, this region is rich in both flat areas and clearly defined uplands. The western part of Guinevere Planitia borders on the so-called Beta Regio. As this vast area looks quite bright in photos, it is one of the first features of Venusian relief that got its own name. Beta Regio is an elevated area which is more or less round-shaped, with a diameter measuring roughly 2,500 kilometers. Its eastern part is the final abode of the debris of the spacecraft Venera 9 and Venera 10, the spacecraft which beamed back to us the first ever photos of Venus back in 1975. They also gauged the atmosphere's parameters and sampled the soil, which turned out to be similar to basalts back on the Earth. All this information allows us to assume that Beta Regio is the largest volcanic massif on Venus. That is why this area offers highest chances to discover active volcanoes on the planet. We're moving on to the north now, to the second largest conditional Venusian continent dubbed Ishtar Terra. It stretches for roughly 8,000 kilometers east to west and approximately 2,500 kilometers north to south. The territory's area equals about 8.5 million square kilometers, which makes Ishtar Terra only slightly larger than Australia. In the center is the largest volcanic massif on Venus, Maxwell Montes. They tower 11 kilometers high above the planet's average level and 7 kilometers above the rest of the relief around. The highest peak in the center of the region is a comparatively flat plateau, measuring roughly 200 by 400 kilometers. The difference in height doesn't exceed 1.5 kilometers, so it is extremely difficult to distinguish separate peaks, as the measurements are not accurate enough. Maxwell Montes are the coldest region on the planet. The temperature here is as low as around 380 degrees Celsius, and the atmosphere is about twice as rarefied as near the surface. Still, it is 44 times denser than that of the Earth. Another thing about this region is that it looks quite bright in photos, which means that the surface of the peaks and slopes is likely to be covered with some substance which reflects radio waves remarkably well. It is thought that it could be metallic compounds with impurities of sulfur like pyrite, hematite or galena. Exposed to high temperatures, these substances can vaporize from the surfaces of lowlands and then precipitate in colder mountainous regions as fine grain reminiscent of snow. While examining the Venusian surface, you can't help thinking this: are all these amazing and mysterious places to remain unexplored by humans? Is there a chance of us ever leaving our footprints on this planet's surface? So close, yet so forbidding. Because the atmospheric pressure on Venus is about 93 times that of the Earth, and the temperature near the planet's surface is on average 737 Kelvin or 464 degrees Celsius. These conditions are so extreme that even space probes specially designed to explore Venus last no more than an hour. As for terraforming Venus, this idea seems totally unrealistic. On the other hand, there are in Venus's atmosphere some layers whose temperature and pressure are close to those of the Earth. In the last century, ideas were even put forward about designing a habitable base hovering in the planet's atmosphere suspended from special aerostats. Still, in reality, the actual possibility of putting such projects into practice remains an open question. And either way, Venus is awaiting her heroes, and her secrets will sooner or later be revealed. Mars lies approximately 1.5 times as far from the Sun as the Earth. In contrast to our planet, its radius is twice as small. Its mass is around 10.7% that of the Earth, and the freefall acceleration on the surface is almost 3 times as little. The temperature fluctuates between 153 degrees Celsius below zero at the poles and 35 degrees Celsius above zero at the equator. The area of Mars's surface is roughly the same as that of all our continents combined. Its terrain is extremely diverse, with some geological features reminiscent of those of our planet and others quite unique and peculiar. The surface of Mars is currently closely observed from the planet's orbit by 8 automatic space probes. The data collected by them reveals that there is a vast light spot in the planet's western hemisphere. This region is the largest volcano in the solar system, and it is known as Olympus Mons. Today, this is the starting point of our tour around the Red Planet. Olympus Mons towers as high as 26 kilometers over the plains surrounding it. This is roughly 2.5 times the height of Mount Everest. It is assumed to be a shield volcano formed with multiple sheets of solidified lava. According to today's assumptions about the planet's inner makeup, there are no tectonic plates under the surface, which is why magma's eruption point can remain in the same spot for a long time, for hundreds of millions and even billions of years. That accounts for the fact why ejected lava spills out to cover incredibly vast areas, with a layer that subsequently turns into a rocky shield. The average diameter of Olympus Mons measures around 600 kilometers, and its area is over 300,000 square kilometers. These figures are comparable with the area of an average-sized European country, like Poland or Italy. A giant depression formed with 6 calderas, or collapsed volcanic craters, is located in the center of the volcano. The diameter of the depression measures around 85 kilometers, and its depth reaches as far down as 3 kilometers. Olympus Mons is so high that the atmospheric pressure at the top is 50 times lower than at the foot. Since the atmosphere on Mars is about 160 times more rarefied than that of the Earth, the conditions on top of the volcano are slightly short of those in the vacuum. That is why the Red Planet's highest mountain cannot expect any visitor probes. The atmospheric density would be too low for parachutes to slow down a descending capsule with a Mars rover inside. With the average slope of Olympus Mons quite small, at only 5%, the volcano's edges and enormous sheer abysses of up to 7 kilometers high, it still hasn't been established for certain how such enormous slopes came to form. According to some assumptions, it was done by an ancient ocean on Mars. Other hypotheses hold sandstorms accountable, which continuously rage in this area. When we climb down from Olympus Mons and fly over its surroundings, we can see that there are lots of overlapping ridges and isolated mountains. Some of these formations stretch as far as 1,000 kilometers from the volcano's edge. It is assumed that they may have formed as the giant mountain slopes were eroding, or else due to movements of ancient ice caps. Whizzing on southeast from Olympus Mons, we will find ourselves in a vast region known as Tharsis. This volcanic upland, formed by solidified streams of lava, covers roughly 1/4 of the entire planet's surface. Its area of around 30 million square kilometers is comparable with that of Africa. Interestingly, the upland is 10 kilometers higher than the plains surrounding it, and its age could be about 3.7 billion years. There are a great number of volcanoes here, some of which only slightly smaller than Olympus Mons. Asteroid Mons, for example, rises as high up as 19 kilometers, which makes it the second highest peak on Mars. With a summit caldera measuring 110 kilometers, the overall diameter of the mountain is over 400 kilometers. A unique natural phenomenon can be observed over the volcano every year for a short time. As sun rays warm the mountain slopes, small dust spirals into a dense cloud, helped along by air streams going upward. This cloud may float up to 30 kilometers above Asteroid Mons and may be scattered by winds across vast areas. Vertical pits can be seen in different places all over the upland. They are quite deep, with the bottoms quite unobservable. The diameter of the largest one measures around 150 meters, and its depth cannot be less than 178 meters. These pits are thought to be collapsed lava tubes. Tharsis is made up of dozens of overlapping shield volcanoes. In the billions of years of their eruptions, great amounts of CO2 and water vapor were released into the Martian atmosphere. Mathematical modeling shows that the amount would be enough to shroud the planet with an atmosphere 1.5 times as dense as that of the Earth. These estimates are in direct evidence of the fact that in the past, conditions on Mars may have been more favorable for life to originate there than now. With its gravity comparatively weak, however, the planet failed to retain its atmosphere and was eventually stripped of it. Moving on to the east from the plateau, we will get to the region known as Valles Marineris. It is a network of gargantuan canyons stretching for up to 4,500 kilometers. The width of the canyon reaches 600 kilometers and it's more than 11 kilometers deep. Images reveal that the slopes of most of the canyons in the central and western parts of Valles Marineris have a stratified structure typical of deposits at the bottom of a large body of water. It is quite likely that the canyons used to be completely submerged underwater in the distant past. There are some truly invaluable paleontological finds to be extracted from the rock deposits in this region. The eastern part of the valleys are areas with a rather chaotic relief. There are vast labyrinths made up of comparatively small canyons, abysses, mountains and plateaus. Further north, the terrain evens out into a relatively smooth plain known as Planitia. Its vast areas became the final resting place for the debris of the Sojourner Mars rover and also for the Viking 1 probe, which sent the first color images of Martian landscapes to the Earth as far back as in 1976. According to the widely accepted hypothesis today, Valles Marineris came to be in the early stages of the planet's formation. Erosion and geological processes were to deepen and widen the canyons later on. One version has it that the systems of chasmatas is thought to have formed after volcanic eruptions on the Tharsis upland. Another version claims Utopia Planitia to be the cause for their formation, which lies on the other side of the planet. This vast round lowland is likely to be an impact crater from an extremely large asteroid that would have hit the planet's surface. The Planitia's diameter measures some 3,300 kilometers. The terrain of the surface itself is rather flat and smooth. There were several attempts to explore Utopia Planitia by different space probes. In 1979, the Viking 2 lander beamed back panoramic images of its surface to the Earth. In 2016, the Charade radar on the MRO probe located rich deposits of water ice mixed with dust underground. In May 2021, the Chinese rover Zhurong touched down on Utopia Planitia. It has covered over 1,000 meters of the red planet's surface by now and has beamed back hundreds of images. Unfortunately, it cannot dig as far down as the water-carrying layer, with the latter as deep as 1 to 10 meters down. In the north, Utopia Planitia borders on Vestitus Borealis, a giant lowland surrounding the northern part of the planet and covering about 40% of its total area. Moving southwest from the center of Utopia Planitia, we will reach Isidis Planitia. The region on its western edge has been the focus of people's special attention for almost 8 months now. Of course, it is all about the Jezero crater. It is likely that millions of years ago there used to be a body of water here that has dried up by now. The Perseverance Mars rover and Ingenuity, the first ever helicopter flown beyond the Earth, have been exploring the bottom of the crater since the 18th of February 2021. The Jezero crater was chosen for the mission because it appeared one of the most promising places to discover traces of Martian life. The crater is posited to have formed around 4 billion years ago after a massive celestial body fell on Mars. The impact crater measured some 49 kilometers. As I've already mentioned, it is thought that it used to be filled with water, and the Hesperian of the geological history of Mars is singled out as the most likely period for that. The Hesperian started some 3.5 billion years ago and continued for around 1 billion years. Atmospheric pressure on the planet at the time is estimated to have been comparable with that on the Earth, with the surface temperature reaching 50 degrees Celsius. Rock samples recently extracted from the crater's bottom by the Perseverance rover are hard evidence of that. They still have to be transported to the Earth for deeper analysis, but it is clear even now that at some point the rocks have continuously been in close contact with liquid water. Perseverance has already delighted scientists with great amounts of useful data, and the mission is still far from being completed. The probe is designed for 14 years of operation, which means that there are still hundreds of finds to extract and kilometers of Martian terrain to cover. That is why our tour around Martian expanses is not yet over. This is Mars. That's what it is believed to look like several billion years ago. Heat and liquid were trapped within the dense CO2 atmosphere the planet was shrouded in. Numerous rivers used to flow on its surface, and most of its northern hemisphere used to be covered by water. However, all this was to vanish, leaving behind only traces on rocks. It is thought that the weak and unstable magnetic field of Mars failed to protect it against solar wind. In hundreds of millions of years that followed, its atmosphere gradually deteriorated, with water vapor breaking down into hydrogen and oxygen. The lighter gas rose up into the upper layers of the atmosphere to float away into space. As for oxygen, it reacted with rocks, which gradually led to the planet getting tarnished by rust and sand. A thin layer of orange dust and perpetually frozen ground. That is all that remains of the great abundance of water on the red planet. To have a better understanding of what is currently going on Mars, we will first have to look in its depths. Thanks to the sensitive seismographs on board the InSight probe, which have been exploring the inner makeup of the celestial body for 4 long years, scientists have some ideas about the processes running in the planet's depths. At the very center of the planet, we can observe a large and massive core of iron, sulfur and nickel. Its radius is more than half the size of the entire celestial body, and its temperature lies between 1800 and 2000 Kelvin. Because of the enormous pressure, most of the core is in a solid state, and therefore incapable of producing a stable magnetic field. The core of the planet, in its turn, is surrounded by a layer of molten mantle about 1,500 kilometers thick. Its composition is heterogeneous and depends on its depth. The lower layers contain various metal oxides, while the upper ones are composed of olivine and silicates. On the outside, the mantle is bound by a massive crust, the average depth of which is estimated to be about 50 kilometers. This is 5 to 10 times greater than the parameters of our planet's oceanic lithosphere, and comparable with the thickness of the Earth's continents. It is also noteworthy that in the northern hemisphere, the Martian crust consists predominantly of andesite, and in the southern hemisphere of basalt, which may indicate that it was formed at different times. Decades of observation have yielded hundreds of thousands of images of the surface of Mars. By putting these together, scientists have been able to produce an incredibly accurate and detailed map of the celestial body, containing many objects. Some of them are quite small, while others stretch for thousands of kilometers and can be seen with telescopes even from Earth. And one such region of interest is Valles Marineris. This gigantic system of intertwining canyons and chasms stretches along the planet's equator for 4,500 kilometers. Its western part is deeply cut by the immense volcanic Tharsis Plateau, and our plunge into the Great Rift will begin almost in the center of the giant plateau. It is here that the unique and mysterious region, marked on maps as Noctis Labyrinthus or the Labyrinth of Night, is located. It is an area of chaotic terrain, stretching 1,200 kilometers from west to east. Here, numerous deep, steep-edged drifts intersect multiple times, dividing the surface of the planet into irregularly shaped blocks. The top is made up of softer, lighter sediment, heavily eroded, while the base is made up of solid bedrock. Over billions of years, the slopes of the chasms have collapsed in many places, leaving behind numerous landslides. It is thought that it was here that precipitation that fell on the surface of the upland regions in ancient times accumulated together and flowed eastwards in unstoppable turbulent streams. Evidence of this can be seen in the traces of deep water erosion, seen at the bottom of most chasms, and in the layered structure of slopes and landslides. In addition, spectral analysis shows that certain minerals that require liquid water to form, such as hematite, opals and dian sulfates, for example, are abundant in this region. Observations show that Noctis Labyrinthus is periodically obscured by dense fog, meaning that it is still one of the most humid regions on the planet. It is thought that the water contained in the soil evaporates into the thin Martian atmosphere during the day, and the high walls of the gorges prevent the humid air from dissipating. With temperature dropping, the water condenses as microscopic ice crystals that slowly settle on the surface, forming a thin layer of frost. As one moves eastward, the bizarre interlocking chasms of Noctis Labyrinthus gradually morph into a system of giant canyons that occasionally intersect. Over billions of years, powerful streams of water dug deep channels in the Martian rocks, and then winds and sandstorms ate away at their slopes. But whichever path we take, it will eventually lead us to the giant Coprites Chasma. It is here that the deepest point of the Valles Marineris is recorded. It lies 11 kilometers below the surrounding plateaus. Calculations show that in ancient times, Coprites Chasma was a narrow and long running water lake, which when at its fullest was comparable in volume to the Earth's Black Sea. The region is believed to be one of the most promising objects for future research. The soil at the bottom may contain traces of ancient microorganisms, and its slopes are quite literally recorded pages of the geological history of the planet and are of great scientific value. As we continue along the canyon, we find that it gradually loses its steepness and gently dissolves into the giant Chrysoplanitia. Here too, however, we see traces of the water element in the form of rounded terraces and elongated islands, probably formed by sediment from Valles Marineris. Similar geological formations can be found on our planet in the deltas of major rivers, such as the Amazon and the Nile. Thus we have made acquaintance of one of the most tremendous and visible evidences of there having been water in the ancient eras of Martian history. However, the giant Valles Marineris rift has only been explored from space. The wheels of a Mars rover have never touched it. To get a closer look at the red planet, we will have to travel far to the east. After flying several thousand kilometers over unfriendly rocky deserts, we finally reach a large crater called Gale. About 3.8 billion years ago, a massive asteroid collapsed here, leaving a deep circular depression 154 kilometers across. At its center there is Mount Sharp, a vast irregular upland area composed of layers of sediment. In ancient times there may have been a large circular lake with a central island. In the present day, however, Gale Crater is known as the landing area for the Curiosity rover. The story of this mission began almost 11 years ago when the Curiosity autonomous probe landed on the surface of Mars on the 6th of August 2012, a symbol of human determination and thirst for knowledge. The mission's goals included studying the planet's climate and relief, as well as searching for water and traces of biological life. Almost immediately after landing, the rover found evidence that the planet used to be much wetter in the past than it is now. The first photos transmitted to Earth clearly show a valley washed away by a torrent of water. The area has been dubbed Peace Valleys, meaning the Valley of Peace, and is one of the clearest instances of evidence of water erosion on the planet. Curiosity then headed east and soon reached a sandpit called Rock Nest. Here it took its first soil sample and found it contained around 3% of water. Next, the rover turned southwest and continued on its way. It crossed the rocky wastelands of the Glenelg region, where ruthless winds had crushed sediment down to bedrock formed more than 4 billion years ago. Then, climbing occasionally up rocky slopes, Curiosity reached the western end of the Bagnall Dunes, studying the sedimentary rocks, which are relatively recent in geological terms. From the desert, the rover turned south and set out on a long and tiring climb up the slope of a small mountain range called Vera Rubin. Along the way, the sand and silica under its wheels gave way to hematite, an iron oxide that only forms when in contact with liquid water. It turns out that the mountain range is largely made up of this substance, which means that in earlier times, the climate in this region was much more humid. In total, Curiosity stayed on Mars for more than 3,000 days, roughly 5 times the planned duration of its mission. Despite all the difficulties and obstacles, it traveled nearly 30 kilometers across the harsh Martian terrain and took 28 samples of alien soil. The probe's chemical analyses detected not only water, but also organic molecules including benzene and aromatic hydrocarbons, while its cameras beamed back to us thousands of photos and videos. Leaving the tenacious Mars rover behind, we will continue our journey and head southwest. Here, Hellas Planitia is one of the largest impact craters on Mars. It is thought that about 4 billion years ago, a massive asteroid with a radius of about 50 kilometers crashed into the planet here at high speed. The terrific explosion left behind a gigantic crater about 2,300 kilometers in size, and millions of tons of rock were crushed and ejected far beyond its limits. Some of these fragments may have reached outer space and then crashed to the planet's surface hundreds or thousands of kilometers away from the site of the cataclysm. It should be noted that at that time, Mars was likely to have been a friendlier and more favorable celestial body than it is now. The giant lowland area that appeared at the impact site was quickly filled with water, forming a large lake or a drainless inland sea. Over billions of years, it gradually shallowed and became what we see today. A huge crater, more than 7 kilometers deep. From a distance, the bottom of the basin may look smooth and flat, but this is just an illusion. In fact, it is covered with numerous small hills and fractures whose appearance is largely accounted for by the movement of layers of subterranean ice. Similar relief occurs on Earth, in Arctic barren expanses and permafrost zones. Due to its great depth, the atmospheric pressure in this region is about twice as high as the global average, resulting in unusual weather phenomena. For instance, from time to time, a misty haze forms over the crater, which is uncharacteristic of Mars. The wind carries some of the mist out of the crater, but its wisps quickly disperse in the thin atmosphere or settle on the frozen rocks. During Martian winter, the Hellas Planitia is entirely covered with frost and when seen from the Earth, appears as a large bright spot. Because of this, the area has long been mistakenly considered an upland, and it wasn't until the end of last century that its true nature was determined. Next, our route takes us to the north, to Jezero crater, which used to be a large running water lake in the past. The Sava River flowed into it from the north and the Neretva River from the west. Traces of these large water arteries are still to be seen on the surface of Mars. These appear as layered deposits of fluvial sediment and large scour marks on the mountainous walls. It was one of these regions that became the priority target of the Perseverance rover, which descended into Jezero crater on the 18th of February 2021. Originally, the rover was planned to land near the Three Forks area, in the Neretva River Valley. However, weather conditions shifted the landing point 1.7 kilometers to the southeast, and the rover was separated from its target by an area of impassable sand called Sator. It was at this point that the unique Ingenuity helicopter got to show its worth. It flew over the surface of the planet and provided a wide-angle panorama of the ancient delta, as well as a unique photo of the Kodiak Plateau, 2.3 kilometers from the rover's landing point. Once the rover had settled in and reconnoitered its surroundings, it started out on a long, arduous journey around the unfriendly desert that separated it from its destination. Traveling south along the very edge of Sator, the rover stopped from time to time to collect soil samples. At the same time, Ingenuity successfully completed flight after flight, beaming back to us many photos of Mars from previously inaccessible angles. On Mars Day 168, the spacecraft turned westward. The idea was to pass along the bottom of the crater, skirt the southern tip of Sator, and reach a rocky ridge along which it would head north towards the delta. However, the terrain proved difficult and the rover was forced to turn back. Pretty much retracing its way back to the landing area, Perseverance set off towards its destination. After smoothly skirting the northern part of the desert, it gradually turned westwards. Eventually, after a long and arduous journey, the rover did reach the delta and began exploring it. This occurred in April 2022, 413 Martian days after it had landed. By now, Perseverance has traveled more than 18 kilometers across the unfriendly Martian desert. It has collected 15 soil samples and sent more than 166,000 images as well as gigabytes of data from various sensors. In addition, the MOXIE vehicle, which is part of the rover's science payload, successfully obtained about 100 grams of oxygen from the Martian atmosphere's carbon dioxide, which seems to reveal prospects for future colonization of the planet. At the same time, Perseverance's seismographs recorded several Mars quakes, enabling scientists to learn more about the internal structure of the celestial body. The Ingenuity helicopter proved just as useful. It has completed more than 50 flights by now, traveling a total of over 8 kilometers, thus convincingly proving that even in the rarefied atmosphere of Mars, it is possible to use aircraft for research and exploration. In addition to desert landscapes and rocky debris, Perseverance occasionally photographs the night sky of Mars. For example, this little white dot here is one of its satellites, Deimos. More recently, Perseverance captured Phobos briefly eclipsing the Sun. This unique observation was not just a spectacular sight, but it also provided astronomers with a wealth of important data. Unlike our planet, Mars has two satellites, which are very small, irregularly shaped celestial bodies. Observations and spectral analysis suggest that Phobos and Deimos are similar in composition to carbonaceous asteroids, but their exact origins are still a subject of scientific debate. One hypothesis claims that they are the remnants of a small celestial body captured by Mars from the main asteroid belt several billion years ago. The tidal forces of the planet probably tore the object into many fragments, and Phobos and Deimos are the largest of them all. According to another hypothesis, a large protoplanet allegedly collided with young Mars at the dawn of the solar system's formation. As a result of this cataclysm, some of the fragments were thrown into space, where gravitation shaped them into two rather large objects. Phobos is the larger of the satellites. It orbits the planet above the equator at an altitude of about 6,000 kilometers, which is about 64 times less than the distance from the Moon to the Earth. Incidentally, some man-made satellites above our Earth drift 3 to 5 times higher than this celestial body. However, Phobos is so modest in size that when observed from the surface of Mars, it appears 3 times smaller than our Moon to us, even at this distance. Another surprising fact is that Phobos has an extremely low average density, approximately 1.9 grams per cubic centimeter. This means that up to 40% of its volume must be hollow. It is possible that this object, like some asteroids in our system, consists of several pieces of debris held together by gravity alone. Due to tidal forces, Phobos is gradually losing height, about 1.8 meters per century. It is estimated that in 10–11 million years, it will be crushed by the pull of Mars into many fragments, and that after another 33 million years, they will finally collapse onto the surface of the red planet. By that time, Mars will be likely to lose its second satellite, Deimos. Currently, this celestial body is moving in a circular orbit with a radius of about 23,500 kilometers, but this distance is gradually increasing. Calculations show that in a few million years, the satellite will finally leave the gravitational influence of Mars and float in space quite independently. Deimos is a very dark object because its surface absorbs almost 93% of the light shed on it. The satellite's small size means that its disk cannot be seen from Mars with the naked eye. Deimos appears to the observer as a pinpoint source of light, even though quite bright. Its orbit makes it appear to drift across the Martian sky towards Phobos, but this is just an illusion. In fact, both satellites orbit Mars in the same direction. Of course, we'll be talking about the main asteroid belt, one of the most changeable and mysterious areas in the solar system. Today, over 300,000 small celestial bodies found here have been given names and numerical designations. Interestingly, their overall number may well reach over 1 million. The starting point of studying the asteroid belt may be defined at 1801, when astronomers spotted a mysterious object in the sky after a long and hard search for the fifth planet. In terms of its parameters, it appeared to be a planet, but happened to be so small that even the most advanced telescopes of the day couldn't distinguish its disk. The researchers saw the newly discovered object as a bright dot like a star. It was dubbed Ceres, and very soon similar celestial objects of this class were discovered. A new term had to be introduced to refer to them. These unusual astronomical bodies came to be called asteroids, which literally means star-like. Apart from asteroids, this area in the solar system contains great amounts of cosmic dust. While slowly spiraling up, its tiny particles scatter sun rays and create a very faint white glow. This glow is referred to as zodiacal light. Interestingly, in equatorial areas of the Earth, it can be seen with the naked eye. For a long time, the following hypothesis used to be widely accepted. Asteroid belt objects were thought to be debris of a destroyed planet. However, today, this assumption doesn't really hold water. First of all, the mass total of all the objects of the main asteroid belt is too small and equals just 3 times 10 to the power of 21 kilograms, or 4% the mass of the Moon. Even allowing for the fact that the greater part of asteroids would have left the belt a while ago, the total mass of the rocky debris still falls short of making up an object with dimensions comparable to those of a proper planet. Secondly, estimates show that large celestial objects cannot form in this area of the solar system on account of Jupiter's gravitational influence. Mathematical modeling revealed that the largest formations in the asteroid belt have never measured over 1,000 kilometers in diameter. The gravitational influence of their mighty giant neighbor rendered their orbits highly unstable, which made potential protoplanets collide and disintegrate into smaller bits. Traces of these collisions can still be observed. Most objects of the main belt group together to form the so-called asteroid families, populations of asteroids of similar makeup and of the same origin. It is thought that they formed as a result of such destructive collisions. The borders of the main asteroid belt are rather blurred. Most of the objects making it up lie within 2.06 to 3.27 astronomical units from the Sun. These boundaries are predefined by Jupiter's tidal forces and are referred to as Kirkwood gaps. Any celestial objects getting into these zones experience the massive gas giant's strong gravitational influence, which destabilizes their orbits. This is the reason why the space object count here is considerably lower than beyond. Kirkwood gaps can be found not only on the conventional borders of the belt, but inside it too. Two of the most clearly defined gaps lie 2.5 and 2.82 astronomical units away from the Sun. The asteroid belt is also conventionally divided into 2 large areas, inner and outer belt. The border between them is a Kirkwood gap with a radius measuring 2.5 astronomical units, which coincides with the highest orbital resonance with Jupiter. It's in the outer part of the main belt that the largest object in this area of the solar system is situated, Ceres. This celestial object used to be thought a planet, then an asteroid, but eventually, in 2006, it was given the status of a dwarf planet. It was possible to do so thanks to the fact that Ceres has a spherical shape, unlike the absolute majority of the other objects in the belt. Its diameter measures around 940 kilometers and its mass 9.4 times 10 to the power of 20 kilograms, which incidentally accounts for around a third of the overall mass of the asteroid belt. This makes Ceres approximately 6,000 times lighter than our planet. The furthest point of the dwarf planet's orbit from the Sun is 2.9 astronomical units. When Ceres is at its perihelion, the distance to our system's center measures around 2.5 astronomical units. At this point, the planetoid's surface temperature may reach 239 Kelvin or 33 degrees Celsius below zero, although its average temperature is noticeably smaller, at just 167 Kelvin or 106 degrees Celsius below zero. The celestial body is thought to be made up of a rocky core enveloped in a cryomantle around 100 kilometers thick. Water ice accounts for up to half of the dwarf planet's volume, or 20 to 30% of its mass. The inner part of the belt harbors the largest and most massive known asteroid in the solar system, Vesta. The object's average diameter measures roughly 525 kilometers, and its mass is around 2.6 times 10 to the power of 20 kilograms, which is almost 4 times as little as that of Ceres. The asteroid's orbit is rather elongated, with its aphelion 2.57 astronomical units and its perihelion around 2.15 astronomical units away. It takes the celestial body 3.6 Earth years to complete a full orbit around the Sun. Vesta is also remarkable for being the only asteroid visible to the naked eye. It can be seen not only on account of its impressive dimensions, but also thanks to its comparatively light surface that reflects about 42% of light shed on it. Besides, the minimal distance between Vesta and the Earth isn't that great, at just 177 million kilometers or 1.18 astronomical units. It is assumed that Vesta is a fully fledged planet in terms of its inner makeup. It appears to have a metallic core made up of nickel and iron, as well as a rocky mantle. The surface temperature of the asteroid is currently fluctuating between -190 and -20 degrees Celsius, but it used to be much warmer in the past. Dark areas to be seen on the surface in the Western Hemisphere are highly likely to be basalt plains. Such terrain features may have formed as a result of volcanic activity or collision events with massive astronomical bodies. The most outstanding geological feature on the asteroid is the giant impact crater referred to as Rhea Silvia, whose diameter measures up to 500 kilometers, and its depth is around 25,000 meters. The second largest mountain in the solar system is situated at its center, towering higher than 22 kilometers. Impressively, the crater's diameter almost equals Vesta's size. It looks like the asteroid collided with a really large object at some point in the past. The collision would have produced not only the Rhea Silvia crater, but also a great number of small bits, which are now classified as the family of Vesta's numerous asteroids. The family counts over 15,000 objects, making up around 5% of all celestial bodies of the main belt known to science today. It is posited that most asteroid families came to be as a result of destructive collisions of two large celestial objects. Sometimes the debris are mutually attracted by gravity forces, which usually blend them into a new astronomical object. However, it would have lost its monolithic nature, and sometimes astronomers informally call such formations rubble piles. For example, Sylvia, one of the largest objects in the asteroid belt, seems to fall into this category of celestial bodies. Its parameters are 384 by 262 by 232 kilometers, with a mass 1.5 times 10 to the power of 19 kilograms. This makes the asteroid's average density just 20% higher than that of water. Estimates show that cavities may account for 25 to 60% of its volume. It takes Sylvia 6.5 years to complete a full orbit around the Sun. The object's orbit's furthest point from the center of the system is up to 3.7 astronomical units. In its perihelion, Sylvia gets as close to the Sun as 3.2 astronomical units. It is assumed that some bits of debris left after a collision are not attracted to other bits, but rather become satellites of the new celestial body. Sylvia is known to have two such companions, Romulus, with a diameter measuring 18 kilometers, and Remus, measuring around 7 kilometers. Their makeup hasn't been studied yet, and it is highly likely that these objects are not monolithic either. Besides, Sylvia may theoretically have smaller satellites as well, which haven't been detected yet. Pallas is another remarkable object in the asteroid belt. It was discovered back in 1802 right after Ceres and is the second largest asteroid in the belt. The average diameter of the celestial body is around 512 kilometers and its mass is roughly 2 × 10⁻20 kilograms, which is approximately 25% less than that of Vesta. The asteroid's orbit is exceptionally elongated and tilts to the ecliptic plane at 35 degrees. That is the reason why the astronomical body is so hard to investigate with probes. As for its orbital period, it takes Pallas around 4.6 years to orbit the Sun, in the course of which the distance to the system's center changes more than 1.5 times. With its perihelion 2.1 astronomical units, its aphelion is 3.4 astronomical units away. Pallas's surface is widely pockmarked with craters, much more so than the larger Ceres or Vesta. Studies of the chemical composition of the asteroid's surface reveal that it mostly consists of silicate rocks with small amounts of iron and water. Just like Vesta, this celestial body is thought to be one of the few potential protoplanets that are still around, which means that studying it may yield important information about the formation process of the solar system. Unlike Vesta, most asteroids cannot be seen either with the naked eye or through amateur telescopes. One of these elusive objects is called Interamnia, admittedly one of the most mysterious objects of the main asteroid belt. This is an irregular-shaped asteroid with parameters 362 by 348 by 310 kilometers, and its mass accounts for roughly 1.2% of the overall mass of all objects in the belt. In spite of its relatively large size, however, Interamnia remains largely understudied. One of the difficulties thwarting scientific progress here is the asteroid's dark surface, which absorbs around 93% of light shed on it. Interamnia falls into the exceptionally rare spectral class F, which is a subclass of carbonaceous asteroids. Research of its reflection shows that the color of the celestial body's surface is even, which means that Interamnia hasn't experienced big collisions for quite a long time. Interamnia's density is not that great, at just twice that of water. The asteroid is thought to be made up of a hard rocky core enveloped in a thick layer of ice. The surface is covered with great amounts of fine dark dust. It takes Interamnia around 5 years and 4 months to complete a full orbit around the Sun. Its aphelion is on the opposite side from 4 largest objects of the main belt, and the distance from the asteroid to the Sun varies from 2.5 to 3.5 astronomical units. In theory, Interamnia's orbit crosses the trajectories of such large objects as Ceres and Pallas, but estimates show that chances of their colliding with each other are small. There are millions of objects in the main belt, from dwarf planets to tiny meteoroids the size of a cobblestone. However, distances between them measure thousands upon thousands or even millions of kilometers. That is why a spacecraft crossing the belt would be running an almost negligible risk of getting hit by any astronomical body. Still, mathematical modeling shows that around once every 10 million years, some remarkable collisions take place in this part of the solar system that produce new debris. Even though a manned mission to asteroids in the main belt will not be in the pipeline for a long while, some of the asteroids there have been studied with the help of interplanetary space probes. For example, the Dawn probe carried out observations of Ceres and Vesta in the period from 2011 to 2016. Quite recently, the space probe Lucy blasted off the surface of the Earth. Even though its main goal is the so-called Jupiter Trojans, the spacecraft will approach the object known as Donald Johanson in the main belt and take its pictures in 2025. Also, the launch of the Psyche project is scheduled for July 2022, with the largest known metallic asteroid of the main belt as its target. Within the mission, the probe is planned to reach its destination by early 2026 and remain in the asteroid belt for at least 21 months while studying the asteroid's terrain, makeup, and magnetic field. Although the solar system is the most explored part of outer space, it is still full of mysteries and enigmas. Meanwhile, beyond it, there lies the vast Milky Way, which hides billions of stars and trillions of planets in its depths. It's still being explored, which means there are many amazing discoveries ahead of us.